Hello, it's Haskell time. So let's write some Haskell, or maybe not so much Haskell. I don't know. We'll write some Haskell, but it may or may not work. So plan for today is to take the code I wrote last week, which is all around deleting people from a list. We have some tests for it. We have quite a lot of types for it now, maybe more than required. And I want to refactor that code. I took a look at it during the week. I opened VS Code to update some extensions, and I saw the code, and I was like, it's not great code. So I want to refactor that, but maybe refactor using the tests and the types as much as possible. And then I kind of opened a can of worms last week where I changed the signature of the actions that we're using. So I'm going to have quite a bit of cleanup work to do to move all the actions over to the new type signature, but also move some code around. So things like persisting the list back to disk will need to move out of the actions and into the main function or some other helper. So that's the plan for today. Maybe do a quick recap of what I was working on, as much for my benefit as for anybody else's. So we focus. Can you scratch pad? No, I cannot. Right. New scratch pad in text. Okay, so I'm writing something which stores a list of names. So Betty, Bob, and Bappy. Why not? It stores a list of people I work with in this case. And an index into that, which is showing who the current person is. So in this case, index of 0 means it's Betty, and then the index goes up to 1. Then the pointer moves, and we're now pointing to Bob. That's straightforward. And then I was adding deletion. I had to think about a few different cases for deletion. So if I delete, if we're currently pointing at Bob and I delete someone after Bob, then everything is fine. We've got nothing else to do. If I delete Bob, then again, we're fine. In this case, what will happen is Bob will disappear. The index is still pointing to 1, so it'll now point to Bappy, and everything still just works. We just delete Bob from the list. It's more interesting if we delete Betty. So we delete Betty from the list, but now the index is wrong. It says the index is 1. We should move the index onto Bappy, which is not what we want to do. So we need to decrement the index. So that's the case when you delete someone earlier in the list, and then there's this weird case where if you delete the last person in the list, so that was set to 2, the last person list, we do that, the index is pointing to 2, which is now nothing. So we need to do some special handling of this. So we say if you delete the last person list, we shuffle the list. We do the sort of normal behavior you get to when you get to the end of the list. We just to shuffle it, and then we reset the pointer back to 0. So we go back to the beginning of the list. So perhaps these might change order, for example. So that's what we implemented last week. And I did it in an interesting way. So I wrote really 2 different functions here. One is the helper function, which says which element are we deleting? Is it someone that comes before? Is it someone that comes after in the list? Is it removing the current person, or is it removing the current person when they happen to be at the end of the list? So I wrote this data type to express this. So there's another case as well where you try and delete someone and not in the list at all. And then what we do is we call this function with our current index and our list of names. Is that right? Or the person we're deleting in the list of names. And then we have a case statement over this these different situations. And I guess when I wrote it, I was thinking it makes it clear what's going on here. So you say if it's not found, then this is the action we take, or if it's removing someone beforehand, the action we take. And by creating the data type, I think I was trying to make it more descriptive of the situation. We're saying, you know, this situation, this result. But when I came back and looked at this code, I'm like, it's a lot of code for something that's quite simple. We have two case statements, one up here and one down here, which are effectively doing the same thing. But in this case, you don't really know what's going on. I think it's a little bit unclear. There's sort of this layer of indirection on top of understanding what's going on. And then it's just a lot of code. I mean, I know the font size is really big here for streaming, but it's like a whole page's worth of code just to work out, you know, how to remove a name from a list. I think there's a name for this pattern. I think it's called shit code. So I think what I want to do is refactor it by basically moving the logic from here just up into here. There's no point, I think, in having this data type. It doesn't really clarify anything for me. We could even we could maybe keep some of this naming. I don't know, actually. I'd be tempted just to move it up into here as is, and then just see what we're left with and if it's worth refactoring anything. Before I do that, then I guess I'm going to go to the spec and run the spec again and make sure make sure make sure the tests still pass, and then I can start refactoring and then make sure they continue to pass as we refactor. I think we're missing a test case, so I don't have a test case for someone not on the list. So I guess it ignores people not in the list. So in this case, we say we remove, who we got on here? We got Beppy, Buppy, and Bippy. I need another vowel. So we try and remove Boppy from our list, or from this state, I guess. It shouldn't do anything, so it should just give us back S. I think that's the case. So can we run the tests? I still haven't mapped a key for running tests. It has to recompile because I added an extra test case. But there we go. Okay, so 5 examples. And they still all work, which is good. So now let's start by just inlining this stuff. So can I grab that for a second? And then our case statement is going to change because it's not, we're not calling remove prime now, or prime. We're calling element index, but we need to extract the names basically. So, what a mess. So we're going to call element index. N is the name we want to remove. NS doesn't exist, but that's actually set to the names of S. Okay, so if it's not found, we return S. If it is found, not even it is found, but it's found and it comes before, what do we do? If it's before, then we give back S, where the IDX is decremented. And the names are set to new names. Typo right there. There we go. Then if we're moving after, we're moving current, they're both the same case. We just return S with the updated list of names. Is that right? Yeah, I think that's right. So remove after, we say s names is new names. That's also this case. So then this one becomes an interesting one. So we're at the end of the list. What we get back in that case is, okay, so idx is 0, names is shuffle. I'm going to move this out into another function in a second because it's quite a lot going on. And new names, and then we can just say otherwise. Do that. And that's S, like that. Okay. Then I think we can get rid of all this code. Hopefully we can get rid of all this code. That should be names. Okay, so we don't have these variables. So we can say I is equal to the index of S, and ns is equal to names of S. I don't know why the indentation is broken here. Okay, so now we can, I guess we can do that. Not sure it's much clearer, but anyway. Okay, so now we can say, so I'm wondering if I can move this guard into a helper. So we could say something like idx before of x is less than I. We just call it before, and then we've got I'm going to call this remove before, and then remove last element or last name, and that's it doesn't use X at all. What's happening? How does this work? So we do the last name, we say if the index is equal to the last element, and the last element before we remove. So we could actually say if I is the length of the new list, we need to add 1 to it. So what I'm wondering here is, can I say remove before, and here I can say remove last name, okay, so they're kind of named. Is this worth doing? I think it's okay. Quite a lot of things in here mounting up, but it just helps us really, so I think we're okay. Do we have something called shuffle already? We do, obviously. I can see I'm calling it here. So I'm wondering if I can just move this into, actually I'm not sure you can simplify this very much. Like, I'm thinking you can get rid of this seed of S. Just because it's a little bit long to read. I'm just going to call it shuffle prime for a second, and maybe later on we'll refactor this again when I find out where else shuffle is called from. So shuffle prime will take a... Oh, it needs to state. That's annoying. So I'd need to pass something in anyway. So passing in the seed is not particularly bad. Like changing this to be shuffle S and new names isn't much clearer. I could maybe put it here. Shuffle names is shuffle seed of S and new names. Not sure how I feel about putting everything into the where clause at the end here, but I think it does make it slightly easier to work out what's going on here. So look up the element. If you get nothing back, then we just return the state unmodified. If we got an X back and it's removed before, then we decrement this. Is there a helper called decrement? Might be. But the names are new names. If return removes the last element, we reset the index and we shuffle. And in any other case, we just return the new names, which is the old names with the current, well, the name passed in dropped out of it. It's still a bit long, but anyway. Let's go back to the spec and run it again. Simon and watching compile and tester runs, which is cool. While I'm here, stack REPL. Is there anything called decrement or deck? No. Is there something called suck? Yes. Is an opposite of successor? Doesn't really matter. I was just going to pointlessly change this to be like the previous. Oh, is it called previous? Wouldn't be called previous, would it? Pred. Predecessor. So predecessor 5 is 4. Cool. That's the thing I wanted. So I can say pred of the index of S. I don't know why I find that nicer, but I think I do. Index of S we have available as I. Where is I used? I wonder if I can just drop that out. Only 3 of these, and I think might as well just write it out. That's even 2 of them. So IDX of S, and here IDX of S. So I can go, and then where does this appear? 2 different places again. So I think we can get rid of that. So I think we can change this to be names of S. And up here, this again, as it was before, it's just names of S. I think that's a bit better. Where clause is shorter and perhaps more useful. Its naming is not perfect. What I might do is change it to something like years before. I don't know. Let's leave it for now. I'll just keep renaming it for the next hour or so. That gets a bit tedious. Okay, so I have the functionality of remove. I guess decrement implies mutable. I guess it does, yeah. Although I'd expect it to return the I guess I meant predecessor. So yeah, I suppose decrement does suggest that you're modifying the variable. I think there's a very long delay today, or certainly there was when I was testing, between me seeing things on the screen and them actually being streamed. So if you say something in the chat and it takes me 20 minutes to reply, it's not because I'm thinking about it, it's just because I'm not seeing it probably. Okay, so we have that working, but we have kind of broken a lot of other things. So I want to change this type. Well, actually, the other thing I want to do is make it work in a loop. Yeah, so making it work in a loop should just be a case of folding over this, but let's find out. So I'll write my test first. And we could say something like it removes multiple people and multiple names from the list. So I'll call it remove prime prime for now. I'll go back and tidy out when I fix the type of the action. So I'm going to give it a list this time of, let's give it epi and bippy. There's a whole bunch of these conditions actually. It's going to be interesting. It removed do. What am I doing? Removes that. Sorry, from S. Should be S where the names, the only person left is going to be Buppy. What was the thing before? It was Buppy. We removed something before and something after it. So we expect the index to be decremented, or to have become the predecessor of the previous one. So that should be 0. So I just need to implement remove prime prime. Which is cool, but it doesn't exist. So remove prime prime is going to take a name. No, it's going to take a list of names. It's going to take a state. It's going to return a new state. And remove prime prime is undefined. Okay. I'm not exporting it. Mine is a little bit tedious. I wonder if I can find a helper that would fix that for me. Ooh. Run the tests. We go, one failure, and yeah, calling undefined. Okay, so remove prime prime. We've got a list of names and a state. And can we then just fold over the list of names? Something. Oh, interesting. Actually, a couple of things. So it's going to take a name, it's going to take the accumulator, and it's going to call remove prime with the name on S. S is a little bit dodgy here. Then we give it a list of names. So, I actually need to give it a state, but not really. No, we need to give it names, but the fold wouldn't really work in this case. So the folder gives back the new names, but what we actually want is a new state. And we're just going to keep calling this. So maybe we do need, maybe it'd be easier to use a state variable here. State variable, state type. So if we change, I'm going here, where's my run state? And let me just put it back to undefined to stop the compiler errors. Where am I calling this from? Exec state is what I'm doing here. So exec state, function, and then the initial state. So here the function has to be state of auto state. We're not going to use state t in this case, so don't IO, and we're going to return nothing. So it'll break all the tests. Let me change these all to be remove prime because this is going to become our entry point. Is it going to have a helper? No, it's not going to have a helper. I don't have a key binding for surrounding stuff, so this is going to be a little bit tedious, but I'll just turn them all into calls to remove prime prime. These are testing individual cases. Okay, none of them will work, but it does mean I can fix it, but I can change it. So it takes a name and this state of auto state. And then say that equals do. What a mess. Then you say S is get. So we'll grab that the auto state from this wrapping state, if you like. What's the key binding? No, that's not the key binding. Is it the ridiculous one? Yes, it's a ridiculous one with all the keys. Do that. Add state. Expecting one or more arguments. Yeah, so it needs to return nothing. Okay. So if we get nothing, then we can just say pure S. No, we can just say pure. No, we cannot say any of those. Okay, how much type that was? Okay, we do nothing. Pure nothing. If it's if we're moving 4, then we want to put that state and return nothing, I think. Okay. I can't use the workflows like this because we can't access S outside of this do context. So maybe I'm gonna have to set them off like this. And delete N from names of S. Yeah, I think it's gonna be like that. It's a bit annoying. So let that, that should be it actually, just put let in front of everything. Okay. Wonder if I could pass some stuff in to these. not easily. Okay, I'll just leave it like this for now. I'm not sure about these sort of inline functions, but let's go with it. The interesting bit I want to do here was say exec state then we're going to pass in a function which is remove oh goodness. We need to pass in a name at a time. We need to call this multiple times, each time passing in a name from this, and then we have the initial state. Now we've got a bit of a problem here because we got an error here. I don't see the error, not the e reduction. The e reduction is a lie because it's not the correct argument to this. So, oh, it's still a lie. Okay, end's not in scope, but this is more concerning. So exec state. Variable not in scope. That's not the error I was looking for. Let's bring it in. Okay, so now it should say we can't use remove because it takes it doesn't take a list of names basically. Well, we're not giving any arguments. This is our problem, I think. So didn't match auto state. Oh, it's a wrong remove. That's a big bit of a problem. Okay. This is the error I was looking for. Cool. So it's expecting a single name. We're giving a list of names. So we want to call this sort of repeatedly. How do we do that? Mapm. I don't think mapm is going to be the answer. So we have a traversable T. We have M, which is a monad, so we get something to MB. So T of A is our list of names. Let's put that again. T of A is this list of names. We have a function that goes from A to MB, which is name in this case, to MB, which is state of auto state. And it gives me back M of TB. It's traversed B's. Okay. Is T traversable in this case? So I guess it's auto state traversable, and the answer is no. It almost worked. It's just that we get the M of TB here, and that's not. That says that whatever's returned here, so in this case M of B is state of auto state, so B is auto state. That needs to be traversable, and it's not. So we're getting the wrong thing back. So it's not mapm. Is it traverse? Traverse. No, it's the same thing, but not under monad. Okay. So is there something inside state which will repeatedly call it for repeatedly call over list, but let the state collect the output each time? Let's have a look at state monad. Maybe. Must try and get Hugel working locally. Be a lot quicker. My convoluted setup though is missing a library it needs. Okay, non-transformers. Control of my that state. I just want without a class. Can probably work from here. Nope. Can you just drop class out there for a second? And get rid of the highlighting. Okay. So we got run state, initial value, return of value, final state, that's what we want. Eval state. Return to final value, discarding the state, it's not what we want. Exec state. Oh, maybe we want map state. Oh no, hang on. With state executes action M. By applying F. I kind of want a fold state. I don't really want to map it. With state is not super helpful, I don't think. By applying F, unless F is some kind of fold. So we go F in this case is S to S. Give it an initial state, it gives us back a new state. I don't think that's quite right. Okay, can we Haskell folds over state? Is that a thing? Maybe state is not the answer I'm looking for here. Mapping with state. I don't really want to map with state. No, because that's taking us from A to B, so that's not really what we want. Eval state is probably not what we want. Traversable, something inclusive, but I imagine we're going to end up with sort of map state. I'd like to see the whole thing together. So add amount is up here. I don't think I'm running eval state over mapm. So add amount goes integer to state int, or state of int, and then returns an integer. Numbers is this list. They want a list back. So I could use exec state rather than eval state here. How would that work? You'd have mapm. Ah, that was surprisingly quick. I suppose it's short anyway. Go back and try running the tests. I'll be amazed if this works. Maybe I've missed a point of something. It works. Okay, amazing. So what have I done? Maphem takes a traversable, takes A to MB, which is this thing, takes an initial traversable and returns state of the traversed list. Oh, I guess, I'm getting a list of auto states back, a list of states of auto states. Okay, I think that's what's happening. And then exec state is running those for me to get the updated state back at the end, because the exec state I'm throwing away the answer, which is empty anyway, or the value here, which is empty. Okay, I think I half understand that. Okay, I'm gonna go with that because it's not erroring and it seems to give me an answer. Am I happy with the tests? I'm gonna write one more test, I think, which is a little bit weird. So what I want to do is, it's again remove multiple people. I just want to make sure that when you remove and cause it to shuffle and then remove again, that it works. So it removes multiple names, including the current last. It's a bit confusing. So what I want to do is we want to do this thing where we put the index to the end. We're going to remove Bippy, which is person at the end. I'm going to remove Bippy first. So what I really want to do is remove Bippy. That should cause it to shuffle. Then we'll remove, we know the ordering from shuffling. So we'll remove an element after, which shouldn't cause any change. So we expect to be Buppy and the IDX of 0. Okay, basically swap these arguments around. Let me do something a bit more exciting. Let's remove Buppy and we should be left with Beppy. But it's only person in the list. Okay, so, one place, then run the test again. Okay, I'm not happy that works. I've had one more test, obviously I'm completely happy. Okay, that's kind of cool. We have our remove now, including this magic. What I want to do is I want to change the type of action, I think. Well, the first thing I could do is I could just plug it into the current definition of action, but I don't want it to save state. I don't think. I really want to move that out so that it happens at the end. Let me go back to main. So I'm kind of thinking hit initial state, do some stuff, and then save state. You just always write the state out again. And save state, where does that come from? Where does it come from? Is it in this file of actions? It is. Oops. We can put it into auto state, I think. Makes sense. Keep all the state stuff together. So save state, it's going to take another state, it's going to run it under IO, and it's just going to write it out to the file again. So we'll export that. And then now we should be able to grab it. Okay. So now I have a problem that our commands, well, it's interesting actually, because they don't need to run under IO anymore, which means that, whoops, go to actions. You know what it's going to be? It's going to be to nothing. So that's a bit weird. It's not to nothing. It's to state to state. Oh, it doesn't work because I'm doing more than just shuffling. Okay, what I think I might do is change it to IO auto state. The reason I wanted to get rid of IO originally was because in the spec, testing stuff under IO is quite difficult, I think, or more complicated than it needed to be. Sorry, I really want to end up with this sort of way of calling remove without calling under IO. Which means that, oops. If I change one of them, I change like this remove to be state to state, then all of them have to change. I could look at returning something a bit fancier, so return the state and some instruction as to what to do. But I'm not sure about that either. Yeah, I think different actions print different things. So maybe the best answer would be to get the current signature working in the specs. So maybe don't do this. Don't do this yet anyway. Okay, so in the specs, like how do we do this? What's the type of HSpec, I wonder? What definition found? Will this tell me the type of HSpec? Nope. I import, oh, won't tell me the type of test. .hspec. Yes. Okay. That's not super helpful. Let's type describe. Takes a string, and I don't really understand this spec with. I don't understand how spec with A is this spec. I don't know what this A is. I guess this A is this. Okay. What I can do is change the type and then see if I can make the errors go away. So I will still return the state. And I can say something like, how do I return this? Well, I can write this and then pure S. No, not that. I can write this. I cannot write that. That does not work. Oh, right, okay. So we now need to pass in S here and then S here. So I could write that. This do and then pure seems like pointless. Not sure what it. I'm not sure how I sort of take exec state. I'm kind of thinking I want to lift it into IO, so I could try just typing lift IO. But that does not work. Okay, let me just do the thing that works for now, because what I really want to do is fix the spec. So now all the spec should be broken. This is where I'm thinking if we lift IO of this. So let me import that. Which one do I want? I guess I control monad state lift IO. And what's this error? This is one that might be interesting. So I couldn't match M0 auto state with actual type auto state. This doesn't seem right. No. Okay. So we've got model IOM, which in this case is state. Okay, so we go from IOA to MA, where M I think M is state. Oh, it's the other one. I want unlift IO. But that's not a thing. How do you unlift? I mean, I don't think this will work. I'm just going to type random stuff into the compiler and see what happens. No. Okay, I tried this last week and I could not get it to work. I mean, one quick way of doing it is to leave this in place. In fact, this is so short I can move it in line. Oh no, I can't. There's a reason why it's in some function. So I could leave this one under IO. And you could say remove so maybe new state. It's a new state. So we could say remove prime prime here. And it takes names. His names are S. No, its name's remove, which in this case is N, and takes a state. And this is not under anything, so we'd say let new state equal that. And then we'd save state. Of new state, I think. So we could just say remove N of S. And we could, oops, give me the hint. So our naming is awful here, but this makes it testable. And this makes it, this does the work, I guess. Yeah, I guess that kind of works. So I'm going to pluralize that because there's more than one N. Actually, does it work? I guess that's a question we could try and work out. So what have we got on our list at the minute? Betty S and Beppy, so we can add Boppy, Bippy, Doppy, and Happy. Very slow. Okay, and we just advance a bit so we're not at the beginning of the list. Oh, run that again. It should be in Boppy now. Okay. A bit bigger. So if we remove, we should remove Doppy and Beppy. And we should still be on Boppy, and those two should be gone from the list. Okay, it does work, which I guess is good. But I'm not super happy about having these three functions where this one only exists so I can test it. But I'm going to leave it in place for now. I don't really understand why I have a run down here on its own. It's called in one place, isn't it? Yeah, I don't think run is quite the right name for that. What's this doing anyway? It's getting it. It's moving to the next person on the list, and then it's calling maybe shuffle. Which is, I could drop the arrow of this and then reuse it as well. So it's putting out the index in the names. It is saying if we can be on the end of the list, then we shuffle the names. Otherwise, no, we shuffle names and then we return a new state pointing to the beginning of the list. Otherwise, we just give the same thing back again. I wonder if I can change it do this and drop the pures out. And then the same for shuffle names, where we pass in the seed. Because I get a feeling in the removal, we're calling shuffle, which gets called here, but we're passing in the seed directly. So maybe shuffle, we can take the seed and that, and we'll say seed here. And we won't call shuffle names because that's doing reseeding. We just call shuffle seed names. Really? Oh. No longer under IO. So now we don't need to be under IO at all for any of this. Then we get rid of do and the let. Just inline this, I think. Yeah, I just inline the whole thing because it's quite short. So shuffle seed names. That's S. There we go. Then we can drop this out all together. Okay, so now the thing that called maybe shuffle will be broken here. So we don't need to lift into IO anymore. And it's going to take the seed from the state. Oh, we're giving it the state anyway. So can we say seed equals seed? Maybe we can say that. Okay, so this no longer needs we don't just assign this to anything, so we just put it. And then we could probably inline this, couldn't we? No help for inlining it. But maybe shuffle IDX equals the successor of the IDX of S. So there's a thing called modify, but I'm not sure it's going to work. No, I think it will work. Okay. Right, does this still work? Just doing random refactorings now, I think. I've kind of lost any kind of plan as to what I'm doing, but it's still working, which is cool. Okay, so I have sorted out remove with the tests, but ended up in a bit of a mess. Really because I can't inline this, which is annoying me. And I can't inline it because I can't run the test. So I'm wondering if I can maybe next week try and work out how to test stuff that's under IO, or how to have a function which is not under IO but would work for all the actions. Yeah, it's difficult because it needs to call save state, so I need it under IO. What's type of save state? It goes auto state to IO. So do I need to do? Oh, what I'm wondering here is, can I just do this? Yes. I presume I can't easily reduce this because it's the second argument. It's basically bracketing these actually. Okay. Yeah, I'd really like to say save state and then just exec state in line. But I don't think I can. I don't think I can because I don't think I can test it. Okay, cool. So yeah, next week I'm going to see if I can sort out the test so I can get rid of this as a separate function. Maybe give us a better name. I can tell now actually. Oh, that's not cool. Also not cool. So we're calling stuff remove prime prime. 3 of these. Yep, so we'll call this remove many. And then I can call this try it again. I can call this remove one. Slightly better naming. I'm just flipping to the spec, which imported them, and I can rename these. So that's remove many. This one I don't need at all. So it's called remove many. Okay. Even with a better naming, I'm not sure about it, but it's better than just remove prime prime. Yeah, so I'll see if I can fix the test next week to drop out this thing. It's maybe not end of the world. And then I got another function to add, another action to add, which is to postpone somebody by moving them later in the list and then coping with the end of the list case for that. Cool. So yeah, I refactored. I think it's better than it was. I learned the amazing exec state mapm, which is cool. Simplified the code a little bit, so tidied up some of the things that were affected by previous refactors. Yeah, next week we'll just come back to it, add a bit more functionality, see if we can test stuff under IO better. Cool. So thanks for watching and for commenting as we went. And yeah, maybe see you next week. Bye.